Wow. So much power. Hello. Wow, that was going so fast. Hello, hello. All right. All right, I'm going to be right back. I'm going to go grab my tripod. I failed to do that. But I'll be right here in a second. All right, sorry about that. All right, so basically the idea here is that you got two separate drives in the same coil, all going to the same place. It's kind of neat. And it gets going super duper fast. That's a 12 magnet rotor, 6 north, 6 south. All right, so this is drive number 1. And then that far, that's drive number 1's battery supply right there, 1257. And then this is what's going into the battery, charge battery. But that's just the one drive. Now, put on drive number 2. Wow. Sure, that's off. That's amazing. That's going so fast. I think it's going like 800, maybe more. turn that second one on again. I think it's amazing. There's a second battery for the second drive, so they're parallel 12-volt batteries. But it gens twice as fast without interruption. It actually goes faster. But as you can see, it went down. It doesn't maintain that energy. That's so fast. Anyway, anybody that wants like a drawing of this, so you got 2 MPNs. You can see that. You got the one coil. It's a trifilar. Got 2 light bulbs. You got the AC/DC cap bank with bridge rectifier, and then you got the charge battery on the bottom. And we'll turn this one on now. So now the charge battery goes up, and the other battery is going up now too, because there's another battery. There's 3 batteries. So I'm not trying to josh anybody or pull the wool over anybody's eyes. Let me show you. It's right down there in the corner. Hey, thank you. I guess. Yeah, and these are all this is just basic connections that I've made with alligator clips. That's pretty much why they're all there. You got one drive here, and then there's one drive right behind the multimeter. But of course, some people can't see the forest through the trees. I don't know, maybe that was a little harsh. There you go. Okay. 13,784 divided by 12. just over 1,000 RPMs. And that's with the second drive on. Whoa, it's so cool. So fast. There's a little drawing of it, a little schematic kind of thing. I'm not that good at doing it, but even I can see what's going on here if I look and just follow the lines. It's easy. This is a trifilar coil with 24, 26, and 32 gauge. So I'm going to hook up the 24. And now the 26. Wow. All right. It's just some PTSD. Well, it gets going really fast. So I've actually had stuff, you know. But it charges like twice as fast, maybe more so. These are 20 and 28 for the drive and trigger, bifilar coils. See, I always wonder if this one's going to get going fast enough to lift up a little bit. Wonder if it's not already trying to do it. But the bearing just isn't going to let that happen. Hello, hello. It's going good. I'm doing it because I like trying different things. There's no, well, I mean, that's about as end game as I get right there. What does it do? It charges the battery at 2 rates. Right now it's charging it at, one pace right here. But if you hook up both, it'll charge at double the rate. And it is all about the frequency, sir. It's what I'm learning. It's what I'm doing right now. You're welcome to join and either share your knowledge or learn yourself. Yeah. And if you look like somebody who really wanted to know the answer to that question, I might answer it. But honestly, I love playing around with this stuff. I'm not trying to, debunk anybody or, come up with the latest gadget. I'm just having a good time, man. That's all I'm doing. So I am going to start learning how to solder, because this, I admit, this is a mess. It's not a hazard, but it's a mess. See, look at the rate that it's going up. And it feels like it's doubling the RPMs as well. Or maybe even more. I don't know. I know that these two wires in this coil are working very well together. As long as both of them have power going through it. Awesome. Yeah, the thing with AI right now is no matter what question I ask, I'm always right. I haven't had AI tell me no once yet. And it's like, are you sure? You kind of. But yes, I've used AI to help me guide myself through. I try not to use anybody's name when I'm using AI. I don't like, hey, give me the Bedini circuit, and I'm just gonna, copy it. And no, I gotta put my own twist on it. I'll do it to a certain extent, but then it's mine. And like everybody that knows me, that from the beginning on, know that I'm like that. I don't replicate. But I do try to explain what's going on. I hate using words like flux and even magnetism. I don't like. Everybody knows what's going on there. It's like just a slight ounce of imagination, and you can see what's going on there. and that is just the way it is. So what drives this is a trigger strand, a 32 gauge trigger strand. So when the trigger strand gets saturated with the 0.5 volts or 0.05 volts, depending on transistor you're using, it'll close the circuit, making either a pull or a push come from the coil. And then when the magnet passes, or when that threshold is below, it'll open the circuit and it'll stop becoming a magnet. And if you get what I'm saying, and I know the closed and the open thing is counterintuitive, but yeah, like when it's open, it's not on. When it's closed, it's on. That's a variac. That's I can plug that into the wall, and I can drop the amount that I use from the wall down to 10 volts, or up to 130 AC volts. That's what it does. So like if I need only 10 volts to run something, I plug that in, then I plug that appliance into the variac, and that cuts down on my bill. At least that's how I would use it, like if I was just going to use it. But that might not be how it works, because I know you got to have 120 volts to make it work. You got to plug it into the wall. I mean, and usually when you plug it into the wall in a 120 volt circuit, you're going to get 120 volts whether you want it or not. So check what I said. That's probably not right at all. But that's what it does, though. It goes from 10 to 130. It takes 120 and you can then drop it or raise it. So this rotor is north-south, 6 and 6, and they're right next to each other like that. So I'm wondering if I can't make one of these and hollow out the center and have it be like one of the common rotators. But you see that magnetic field is all the way around, so it would be more like a drone style counter rotator. Because I was viewing how these drones were built, and they got the tight magnets around the outside with no gap. So that's awesome. And I think those ones can lift a car. I think this is one of the more cooler rotors that I've built. Well, I shoved it up there, so it hopefully won't mess up. All right. That is going super freaking fast. That's awesome. Wow. Yes, sir. All right. Counter rotation time. Gonna work, or do I need to help it? See, that's the problem with having a half-inch spacing there. There's not a lot of torque. So a little choppy. I think it's a combination of this stator being wobbly and the weight being a little off. I don't want this thing shaking around so much. Now they're going that fast. But here, spun that the wrong way. So we're gonna have to do these one at a time, I believe. Uh, so there's 3 drives on this one. There's a reed switch drive. There's 2 NPN drives. It's a 90-degree electromag, so works good with the 8 magnets. It runs a lot more smoothly on the reed switch, but the reed switch only works really good with the 6 magnet stator. This one right here. And there's a lot less space in that hole than there is in this one. Maybe I'll set that up. Alright, let's do that. Because I like the reed switch, it's nice, and we're going to do the straight one, not the one that spins. So if anybody's got anything they want to say, I'll be there in a second. The wheel's still spinning. Power's been off for a while. That black Stator is a nice little flying saucer. And then maybe I should try replicating, but I don't even know how to solder really good, so I'm not in any hurry to do that. I don't even know how to solder at all, actually. But I think this schematic is one of my better ones for trying to use symbols and stuff. I'm going to make a short with that in it. So, in order for them to work with the rotors, you want all the maglevs pointing north up. That didn't take too long. That's pretty fast. That's how my day goes, man. I'm always changing stuff. What works better? I got so much stuff. I mean, why not try it? Because I'm not an egghead, dude. I don't like just sit there and do math equations and say, oh, it's done. I did it. It's like I probably should know more math. No joke, but it's like playing chess. You can do all that on your head or on a piece of paper, but you want to play on the board, right? With somebody. That's what you want to do. Huh. I'm wondering if all my magnets are straight. I knew it. For a reed switch, it's got to be a monopolar, as far as I know. That's weird. Yeah, that's the way it's supposed to go, but... Huh. Let me try this. Yeah, maybe I went the wrong way with those. Doesn't seem like it should matter, but I think it does with the reed switch. See, it was 22.5 degrees offset to the south side of the coil, so they all had to be facing south inward for it to work properly. It's alright. It's the way I usually run it. Thank you. All right, awesome. We'll have that one going. Wow, that is going really, really fast. I'm gonna have to get a tack strip because doing the divided by 12 is too much. I don't want to do that all the time. So I'm gonna get some tin foil, and I will be right back. All right. So I'm working on printing my 4th stator. And I'm praying this one isn't going to be all wobbly, that it'll be pretty sturdy, and it'll be a combination of all the ones I've done so far, plus a new design. So I decided not to do the cone thing, and I'm just doing a cylinder. Alright, let's see if we can get a reading on that. So, it's like 252 RPMs. Yeah, that was right. Okay. It's working. Yay. Almost 700 RPM. 718. Sweet. 823. $924. Awesome. $1,058, 67, 77. This is 24 gauge. 1139. So that was going up well above 1200 RPMs. That's awesome. We'll do dual drive next, or we'll do the other drive. We'll do that. While the primary battery charges, we will run the 20, I believe it's a 26 gauge strand. All right, it's slow. I mean, it's speeding back up. It's at 1020, so 1020 RPMs, 1034. That's awesome. All right, let me check this out. All right. $10.44. All right, I'm gonna hook up the other battery in just for a few seconds though. $1,200, $1,300. Holy shit, that went up 100 RPMs in one reading. That, you know, I said 1,200. Oh, I hit the test button. Oh no. Anyway, it said like 13 something on the next reading. Anyway, I love having a tack strip on that. It's so fun. So fun. I think this is a really nice, balanced, light rotor that doesn't throw its weight around a lot. Each magnet node is two magnets that are square, flat square neodymiums. So there's a nice field, but it's also a small field. It's not like this. It's just a flat. So I'm going to throw all three switches on that in a second. All right, here we go. Wow, it's so responsive and it's so fast. Like if I let that run without having my finger on it, it would get up to speed very quickly. Wow, that's off. That's off, man. That's awesome. Had to check it because it's going so fast. So what this is essentially this in reverse. So you got the electromag on the rotor and you got the permanent mag on the stator. So Mike suggested that I leave everything on for 10 minutes before I start taking readings. So I want to do that. I don't know if I can do that, but I want to do that. Yes, yes, there's a battery in the counter rotator. Well, you know what I mean. In the electromagnetic rotor, there's definitely a battery on the rotor. Uh, do you think there's anything else that goes with that? No. Some have two batteries. I believe there's two batteries actually in parallel running that circuit. So instead of 2,000 milliamp hours, there's 4,000 milliamp hours of 12 volt power. I like it better that way. For one, all the stuff that I'm working with right now will fry at 24 plus. I need to add certain things like a commutator switch for this one will drastically decrease the amps needed to run it. Look at that baby go, man. That is freaking awesome. Let's see what it's doing. 1,216 RPMs, and that's just with one drive. And these drives help each other. Amazing. But I believe a transistor will always be better than a reed switch. Ah, yes. Hello, society. How you doing? All right. So this is now going about 1250 RPMs, and I haven't turned on the dual drive yet. Should I do that? Let's see how fast it's going now. 1220. We're almost at 12.5, 12 and a half volts. Yeah. All right, here we go. Wow, I think it went down a little bit. See if that catches up. 1160. That's not what it usually does. Wow, the primary battery just went up a volt. Or a hundredth of a volt. That's new. Because it's on right now. Let's see what just the one drive does. Okay, so there's not enough energy going through to maintain. Huh. And that might be, I've been playing with it pretty hardcore. So I might have blown that transistor just messing around. But we're going to stop it and we're going to start it from that drive and we're going to see what happens. All right, I'm reading. Yes, sir. Where a small amount of voltage is used to trigger these NPNs. 0.5 of a volt or 0.05 of a volt, depending on which type of transistor you're using. And then, like I said, like any voltage is going to have a small amp with it. You don't even need to second guess that it's there. It's there. Because electricity is wattage. That's what it is. It's wattage. Yes, sir. Alright, so I think that was working. Maybe if we start this one first, we'll get a better result. $6.50. Yeah, that's getting faster. Holy cow. I love this rotor, man. I love this rotor. But yeah, from the magnets to the trigger, there's many different ways said on how that happens, whether you draw it from the atmosphere, which I tend to lean towards. You know, the energy's already there, you just need a way to harness it. That makes sense to me. But yes, the magnets do induce the base of the transistor. And the way I see it, like especially over here, the lighter I have to push it, the better it is. So if I don't have to just whip it to get it to start, that's good. You know, if I can just nudge it and it starts, that's good. $10.44. All right. Are we ready? Is it going to make it slower or is it going to increase in speed when I connect the primary drive? Let's get a reading before I clip it up. 1067. I'll be right back. Yeah, my print is pretty much, I don't know, like 20% done. $10.77. Let's hit it. $12.31. you hear that humming? Whoa. Whoa. I don't know, but I just like saw things way over there start moving for some reason. 13. Maybe it was the wind blowing. And I just, something in my glasses or something. This thing is mean. It's awesome. So this is the first time I've actually had a dual drive setup work and function the way it's supposed to, with the double charging and like, you know, some more speed. That's so cool. Alright, so I'm going to turn on all three. I think that's the wrong way. See how much I had to touch that? These are 26 gauge drive coils. .32 gauge trigger strand. So you got to know where you start your coil, okay, and then you got to know where your coil ends, and there are your two ends, and then the trigger coil beginning point hooks to the base, and then the ending point hooks to the emitter of the transistor. So there's your base connection, there's your trigger connection, all done. And then you go and you take the power supply and you put it in the positive end of your coil, which is the beginning of your coil, your drive coil. And then the other end you connect to the collector of your transistor. You always, in my opinion, want to put the coil first to help mitigate damage to your stuff. It's added resistance. Why wouldn't you do it that way? You know, that kind of thing. And then you take the emitter and you connect it to your power supply, the negative end of your power supply. So you got your one, and then this is where the two comes in for the collector. There's a light, either a neon light bulb, or I use halogen bulbs. They're 20, let me think here, they're 30 more resistance or voltage, so it's 120 volts instead of 90. And then you connect one pin of that to the collector and another pin to the emitter. And there you go. You got your one base connection, your two collector connections, and your three emitter connections. And that's only half the circuit though. That's the 1, 2, 3. In my opinion, that's as simple as it can get. It's not Bedini. It's Bedini-esque. Because, you know, when you make a schematic, you have now solidified your way of building that. That's how you build it. That's it. You're showing everybody how you build it. When you commit to making a picture or a pictogram of your circuit. Can you make another one? Absolutely. But, you know, I like to only do that unless it works good, you know. Not just every one I do. I like trial and error. That's how I roll. I like doing it. That's how I do it. I know a lot of people don't even respect that, but I mean, that's what I do. And yeah, I'm picky. I gotta want to do it to do it. I think soldering is going to be one of those things that I just make myself do it. You know, got to get that in there because, you know, look at this. Who can follow this just by looking at it? Nobody. A lot of people solder work I can't follow, but I mean, this is hard to read. So the second half of the circuit, you need a rectifier diode coming off the collector. So the anode is plugged in to the collector and the cathode is pointing outward, leading away from your circuit. And then you connect that to the positive end of your charge battery. And then you connect the negative end of your charge battery. And this is where things differ. You know, in SSG, you're supposed to connect the negative end of the charge battery to the positive end of your coil. But I have it, the negative end is connected to the emitter. So now you have one connection for the base, 3 connections for the emitter, or I mean for the collector. You got your light connection, you got your coil connection, and you got your battery connection on the collector. And then the emitter, you have 4. You've got the light, you've got the ground for your coil, trigger coil, you got the battery ground for the drive, and you've got the battery ground for the charge. Both battery grounds. So the emitter becomes your universal ground. And you've seen how this thing charges, man. It's not wrong. Okay? It's mine. It's not wrong. I did it on purpose. And I mean, I would hook it up the other way, but I'm using this cap bank, so I'd have to actually undo and change a lot of connections just to set that up. But I know what happens. I'll just explain it to you. When you connect the negative end of the charge battery to the positive end of your coil, the speed in which the rotor goes is exponentially increased. But the rate in which you charge slows down until you reach a certain speed. And that's what it's all about. It's about how fast you can do it without capacitors. You know, that's what it's all about. Oh yeah, these little things right here are like capacitors, homemade capacitors. I need to buy more table salt or potassium chloride, one of the two. And they're gonna be like this. And I'm gonna you know, make each one individually, and then I'm gonna wrap them together, and then I'm gonna cover them up. I have no idea how to use one of these things, but I hear that they can hold a charge if you build them right. So each one of the cells that I'm going to make here are going to have 6 of those aluminum rods in a honeycomb shape, and I got 3 of those rods. They're like 2 feet. Yeah, you have no idea what I go through on a daily basis, man. Like, I'm gonna get the hang of it, but I shake. I have like tremors. So anything that requires your hands to hold still, I'm not gonna be good at. I shake like I got Parkinson's, bro. It's not a joke. I don't even know what it's about. I guess when I'm not doing anything, I'm okay. But when I actually try and focus or hone in, it's easy for some people, no doubt. I got a friend that can solder. It's amazing what he can do, man. I get kind of jelly, but no, no. Anybody that says it's all in your head hasn't had a problem in their life. And that's probably true. And that's probably good, you know? Like, if you had a problem, it was probably with money or something like that. But I've been in like 8 car accidents, 2 of which were my fault. But yeah, that's I got some like nerve damage or something. But I can like, if I sit there with like one of these clips and I try and put a 32 gauge wire in there, I'm sitting there for like at least a half an hour. So yeah, I'm gonna start to solder, but I wouldn't necessarily sit. We'll see. We'll see whether it's gonna be easy for me or not. I think it'll be all right. I think there's a few things that can help me, you know, like so that I don't need to be the one holding everything. Because that would just not be good. That would not be fun to learn or do anything like that if I'm the one holding it. At least not right off the bat. All right. Can't wait. I got my kit under there. I just want to buy some solder with flux in it already. So I don't have to do the flux too. You know, just get the solder with the flux in the middle already. Yeah. Oh. And I got some silk, silver PLA that I'm going to be making the next, at least half of the next stator with. So it should look all shiny and stuff. Excuse me. Alright, so I'm going to turn both of these MPNs on. Maybe you can't hear that. I need to center this. And then all three, the reed switch and the two NPNs. So I need to get, alright, I have this piece. This is an infrared receiver. And then I think I need to hook it up to a relay, which will replace the switchboard. Or it will be, incorporated into the switchboard somehow so that it can cut the power without needing to throw the switches. So you throw the switches to start it, and then you hit the remote to cut the power, like right here. I mean, it's I don't know, maybe temporary, but that might be good enough to put this in a different category altogether. Right now it's my tabletop toy. I use my finger to stop it and start it, But, I've heard good things about things like this. I've heard MRI machine. That's awesome. OTCX-1. It's a time travel spacecraft or craft. Uses the counter-rotating concept. Except it's really elaborate. That machine is amazing. So it's got 12. 1 second. Hey, Beat. How's it going? Okay, cool. Beat, you are the man. Welcome. All right, that was. That's a message. So that was somebody that wants to sell me something. I forgot what I was talking about before that happened. I love that, man. But the responsiveness. This is the rotor that I made the video about responsiveness. So I'm just going to turn this on because it's 32 gauge. I thought I had to do it again, but I didn't. It's like, you don't even have to touch it. But I can't wait till this next stator is done because I have a feeling it's going to be a lot more sturdy, and it's going to be it's not going to wobble like they all do, the ones that spin. Yeah, well, we could hook up the counter rotator part. It can do, the electromagnetic rotor can do both. But yeah, man, I want to hook that up. The 6 magnet electro. This should be awesome. There we go. Now the thing is, the maglev fell off of it, so I'm just going to remove all the maglev. Alright, so it moves. That's good. Well, that was cool. Alright. There we go. Heck yeah, man. The 26 gauge and the 32 gauge together work like really well. I think what that is on the shaft is the iron powder is like all over the stuff, so it makes it really the bearings grind. Let's see there. Oh yeah, the infrared toggle switch. See, with 1 MPN, it moves. I love this thing. Woo! Accounting. Yeah, you can use the same transistor to run both of those circuits. It's just an added connection. Basically, it connects your circuit to the charge battery with the 3-4. And then the 1-2-3 is, oh, it's a wasteful circuit, but it just runs stuff. And then the second, the 1-3-4 changes it into a charger. And everything about it is Bedini except where you're grounding your negative charge battery. Where you're putting the negative of the charge battery is different here. And it makes it's night and day. That's the difference. You're like, how can it be so different just clipping it here or clipping it here, but it is so different. But both of these drive circuits are hooked up that way to, dump the energy into the battery. So when I turn one on, it'll charge at a certain rate. When I turn the other one on, it'll charge at a certain rate. And when I turn both on, it'll charge at double the rate, or, at additive rate. One plus the other. Maybe it's more than that. I think the speed comes out exponentially. The speed, if you do it right, if you let the second circuit saturate completely and get up to its max RPM, which is about 1080, and then you turn on the second, or the primary circuit, the 24 gauge. Ooh, you're pushing 1500 with a bearing. That's awesome. Once it starts getting past that, I get PTSD, man. I shut it down because I've had lots of bad things happen at high rates of speed. I had on my birthday, a birthday live stream I was doing. I saw physics in action, equal and opposite reaction, and the rotor went that way, and the magnet went that way, and it was just a little tiny magnet. One of these, not tiny, but one of these magnets flew at 0, and the rotor and all the rest of the magnets and the shaft and pretty much everything else went 180. So, boom. And that was from the centrifugal force. It was going like 2,700 RPMs. It was an axial flux motor that I made. And it just shot right out of the PLA. It just blew right out the side. I think I only had 3 wall loops. But I've learned, since now I do 4. 4 wall loops at least. Oh, I don't know. I like doing this stuff. And don't get me wrong. I don't necessarily like doing it the way I was meant to do it. I guess there's a lot of I don't know. I don't know, man. It's the way the cookie crumbles. If I had gotten an electronic degree of some kind, I probably would have done something with it. But I didn't know anything about it when I was going to college. I love that sound, man. It chirps like 1 2 1 2 1 2 1 2 1 2 1 2 like that. You can hear it like. It's different than just one. You turn one on. That's easy to handle. But two. Wow. So cool. Is that like the helping hand? Yeah, I was gonna get one of those like helping hand type things for soldering. That would help me out a lot. I know that would, and I think. Yeah, I just wish I had like didn't. And then it's weird. Sometimes it'll like go, boom, like a totally involuntary motion. It's ridiculous. $12.50. Nice. 12.51. Now, what is the use for a dual drive? I don't know, man. There's a whole, when they make up stuff, okay, there's a whole room of people just making up names for the thing, okay? Right? And then, I'm not talking about the patent and drawing the silly picture of what you're doing. I'm talking about the people that are actually going to make it into something. Because I would say 95% of the time it really isn't you that's going to do that. I don't know. You get a chunk of money for your intellectual property. But, that's how I see it working. I can see how it doesn't work. I can see that as well, That See me, I'm poor. I know that even if I come up with something great, I'm not going to be able to do much with it. Because almighty dollar, no matter what it's called, the dollar, quid, yen, all that, it's all the same thing. Okay? It doesn't matter which currency you use. It all, you can do a collab. You can work with people. Essentially, because you have no money, you're working with them. And you work together the best you can, but that's probably not why people work together, man. People actually like other people sometimes, you know what I mean? People actually like working together with other people sometimes. I know I do. I just lack rapport, man. I do not know how to behave or act around people. I say what's on my mind. And sometimes it's not even real. I got, I don't know. I don't even want to go into it, but it's severe and it's real. And I say live through it before you go and say it's all in your head. I say you live through it first, and then you can say it's all in your head. And you would never say that because you've experienced it now. And yeah, it so matters. Like drawing this on a piece of paper and building it, two totally different things, man. Now, I've drawn this and built this enough times for it to be like the back of my hand, but it's like, that doesn't matter. I think, yeah, if I'd done it so many times, I should be okay, decent at building it. But I've got over 4,000 videos, almost 4,500 shorts, videos, and live streams. I try to, mix it up. I try to keep it live. I try to not do the same thing over and over and over again. Counter rotation kind of got me into that sector. The amount of money I have has put me firmly in that sector of having to, take a different approach. Like none of my videos are like a handful of my videos are edited. A handful are edited. Uh, yeah, I see my edited videos not. I didn't see a big change in performance. And then I tried some AI splicers. So I put my long form video into the equation, and they would pump out, 10, 15 short videos using that content. And there was no AI voice or anything like that. They just did all the splicing. And yeah, I didn't like it very much because it was really out of context. You know that? It's really out of context because of where they put the splicing. Now, if you do an edited video and then put it in, I bet you that would have so much better, outcome. All right, B. Hello. Sorry, I got like really into that one. But yeah, man, if it feels right and good, I'm willing to change up what I'm doing. You know, I just it's not quick and easy. That's not what it is. So, I mean, whoever's thinking that this is quick and easy, got it all wrong. That's all in your head. So each one of the circuits is hooked up to one coil. So each circuit reacts to each magnet on an individual basis. Yeah, Beat, if you come up with a good counter rotator, man, I'd love to see that. So this is virtually the same style. I've got two styles. One that has two coils on each node, and one that has the one coil. And that's the ones that we're using right now have one coil on each peg. However, I have another style. See how the peg is longer? It can fit two coils on it. And so you put your generators on first. You don't want to have your generators out because it'll lens up. So you want to have your generators distanced from the magnets. You want to have your drives close to the magnets, not the generators. So every time, and this is the cool part, every time you hook your generator coils in series, every time a drive coil hits and the circuit is closed, and you're getting you get a hit on your generator coil from that, a powerful hit. It's not 100% because it's through proximity, but since it's in the same, it's not in the same on this one, but since it's like really close, when this one hits, and it's right on the pole, all the coils and bobbins are the same size, roughly 5 ounces per coil. Doesn't matter what it's 5 ounces. All my 30 gauge coils, 5 ounces. All my 20, 28 coils, 5 ounces. All my 26, 32 coils, 5 ounces. Go figure. Really neat. Okay, so these capacitor nodules over here that I'm working with, see, I isolated it, I got the paper on there, then I wrapped it up in tape, got it tight, and then this twine here, this butcher twine, is soaked in salt water like 3 or 4 times. And then I guess put more paper around it and then add another layer of aluminum. I think having the added resistance is going to increase the minimal amount of voltage that I'm going to get. Kind of like a serpentine coil in a spiral. Yeah, no, hey man, that sounds like a great idea. We gotta talk about that more though, because I'm having trouble visualizing it. Would it be on the outside or the inside? Because if I can run, I got an idea here. All right, this might actually work to the point where I'm not going to have to use a battery anymore. I gotta have one built like that. Have copper, just a sheet of copper down here on the bottom, and have the brush, and have brushes, and have the spiral coil go up the middle, and have there be another plate in here. That each coil will have their own brush. I don't really know much about brushes. I just use the stiffer wire to make brushes. But that way I can hook up the power supply. We could go 75 volts. Or we could hook up this. This can go up to 345 volts. This one's easier to stop. It's brushing against the side though. That's why this one worked. The inside of the hole, the sides warped, and you can hear it brushing on there now. So when it gets going really fast, you hear it really good. I think 24 gauge is awesome. I mean, that's only 300 turns of a coil, but that's 24 gauge, and that's what we've been watching. So if I ever badmouth 24, I take it all back. I don't have much 24 stuff going on, but I got this. This is awesome. So the rotor's got 6 north and 6 south on it. Now I think the next step with this type of motor, with having the magnets on the rotor, is to go 100% magnetic flux. So get the magnetic shaft, cap it, have your south magnet on the top so it attracts, and when you cap it, you're going to have the least amount of surface area that you can touching the south magnet on the top. Then you put a south magnet on the bottom, but a lesser strength, and that'll keep it lined up. And then I believe you're going to want your magnets touching your shaft. And 120 is heavily suggested. But I've experimented a lot with suspension without the magnet on the bottom to keep it straight, so it would pendulum all the time. But yeah, it's awesome. I hope I can make something like that. Oh, you mean using the copper infused PLA to make a design, pretty much? Because the copper infused PLA doesn't conduct. There's too much plastic in it. But I do have tape, copper tape, that I could like run down the middle of it, and that stuff is very conductive. Yeah, I made a bunch of copper infused PLA stuff back when I had money, and I was disappointed that it wouldn't like transmit through. You do get the magnetic field from the iron infused PLA though. The magnetic, like it'll hold your magnets in place. This one right here is iron infused PLA. That's all iron infused right there. And then this is carbon fiber on the top. And it's holding these mags in there. It would look neat, man. That would look awesome. And then I would add the tape just to make it, work. Now I could like make my initials on this thing. That'd be awesome. Yeah, this next stator that I'm printing is not going to be a neutron. It's going to be a cylinder. I'm just trying to get one that isn't going to wobble on me. This one's pretty good without a maglev. But I want them all to be, spinning as freely as possible. Alright. Just trying to think real quick if there's anything I'd like to do. Yeah, I'll show this one more time. And then I got one other thing to show you guys. That's the dual drive charger. That's this setup over here. So you got your 2 MPNs, you got your 1, 3, 4 connections, you got your trifilar, you got your 2 drive batteries, and then you got your 1 charge battery, and it's all going through this AC/DC bridge rectifier. Simple as pie, right? Clear as mud though. And then one more thing. All right, so that is the electromag connection grid for the one that's on there right now. So you got your reed switch connection going down the center. Then you got your X2820 circuit. There's two of those, so it makes an X. And then the two 30 gauge, which are across. I haven't done anything with those yet, but they're supposed to be hooked in series and then connected to the bridge rectifier. So, and look at what it looks like. Look at what it ends up looking like there. That's atomic. It's a nucleus of some kind. Now, am I saying that my counter rotator has atomic power? No, I don't. I'm not saying that at all. I'm saying the connections look like an atom. All right. Thank you much, everybody, for chilling with me. I really appreciate it. But I'm going to have to go. I might be back later tonight if you want to come and chill. All right. Peace out. Have a wonderful day. Bye now.